Hello, chemistry students. Let me introduce you to one of the easiest ways to balance an equation, one of the craziest things and most annoying things that students have to do. So I want you to look at this here and realize, okay, balancing, I can go back and forth, left and right. I can count up all the atoms and figure it out that way, or I can find out a better way. Now, obviously, you're going to end up putting a number in front of these numbers. You're going to put like whatever, 4 or what, 2, and that's what you're trying to figure out is what numbers go up in front in order to have the same number of hydrogens on the right side as the left. Now, I know there's sometimes easy ways to figure it out. And if, for example, we can see there's 2 hydrogens here and 8 there, so there's probably a 4 there. But let's instead find an algebraic way to do this. Let us use A, B, and C. Okay, so now I'm just going to make this extra large. We're going to put we have a missing A in front of our C3H here, right? Plus a missing B in front of, you just go A, B, C as the missing variables in front, a missing B in front of our O2. And you continue, and now we're going to look at the right side of the equation, like that. And we can say that there's a missing C in front of this CO2. And then finally plus a missing D variable, some missing variable in front of this. Like so. Once you get this technique down, you'll love it, by the way. And now we're going to say, okay, we're going to look at our independent, now you're going to count up your independent elements, C, H, O. Those are the only 3 in this thing. And you're going to say, okay, on the left side, how many carbons which one has carbon in it? A or B on the left side? A does. How many carbons? 3. So we're going to say 3A on the left side. And now we're going to count up which ones have carbon on our right side. I see only carbon in the C one, which is fine. And sometimes you'll see it in both, and you would just add them up in both. For instance, we'll see it with oxygen. And I only see one C. So it's 1C. And then we're going to move on to hydrogen on the left side. How many hydrogens do I see? It's only on with the A. And I see 8 of them. So 8A is going to be the equivalent. And where do I see hydrogen on the right side? I see it with the D. And I see 2 of them is going to be equivalent to 2D. And then O on the left side, I can only see it with the B. And there's 2 of them. So it's 2B. And on the right side, here's the interesting part. It's in both equations. It's with C, so it's 2 of them with the C, and there's 1 of them with the D. Great, so now we have these algebraic equations, and to make life easier, we're going to just start with A is equal to 1. Well, if A is equal to 1 on the first line, we see that 3A is equal to 1C. And if A is equal to 1, we can discover that C, in order to be equal to 3, must be 3. Right? That's the only way to balance this equation. So we're immediately going to say, well, A is 1 and C is equal to 3. We're going to go to the next line. We see 8A. 8A is equal to 2D. And we can tell already that we've already assigned A to equal to 1. And 2 ends up being, how do we balance? We got 8 on the left. Well, for that to work, D must be equal to 4. So D is equal to 4. In other words, how do I make the left number equal to the right number by replacing this with a number? Well, the only way it works is if D is 4. And then finally, we have the last one. We have 2B, and that's the one we don't know. But we know it's equal to 2C plus 1D. And we know 1D. We've figured out D is 4, so 4 times 1. We've figured out C is 3, so 3 times this. What is 3 times 2? It's 6. What is 1 times 4? It's 4. What's the total there? 10. What number can I make B so that 2 times B is equal to 10? Well, B must be 5. 2 times 5 is equal to that. So my last one here is I make B is equal to 5. Sometimes the lines don't work out and you have to skip to the next line. But now going back to our equation, if I replace the A with 1. Technically, you don't even put the 1 there, but the 1 goes there. My B with 5 goes there. My C with 3 goes here. and my D is 4. And if you add them all up just to make sure, you can do left side, right side again. Just if you get uncomfortable, just do it the first few times. There's 1, 3, so I got 3 on the left side. And how many do I have on the right? I've got 3. H on the left side, I've got 8 of them, because there's 1 times H of 8. And on the right side, I got 4 times 2, 8. And on the left side here, I've got 5 times O2, so I got 10 of them. And on the right side here, I've got 6 of them. And 4 times 1 of them, 4. Now you can stop the video there, but I shall continue with a few more examples and see if it works. Okay, we're going to get rid of all that. We're going to try this. And you get faster and faster at it, by the way. Okay, so on the left side, I'm going to just replace this with A, aluminum, Al, plus B, HCl, is equal to, on the right side of the equation, C, Al and Cl, and I can't do a little subscript, but I'll do it like that, plus D, H2. And then I'm going to look at each thing. I can see on the left side for for Al, what do I have on the left side? I just have 1A. And then it's going to be equal, and what is it equal to? How many Al's on the right side? I just see 1C, because there's 1 Al in the AlCl3 component with that C. Then if I look at the next line, or the next element, C, on the left side I can see I have 1B because there's 1 hydrogen. And on the right side I can see DH2, so 2 times D, I can see 2D, so 1B is going to be equal to 2D. And then as I move on to my chlorine, I can see on the left side I just have 1 chlorine that goes with the exponent B. And on the right side I see I have 3 chlorines, and it's with C, so I go 3C. Well, I'm going to start and set up here. My equation is just going to be A is equal to 1. So if A is equal to 1, I get 1 times A on the left side is going to be equal to 1 times C. How do I make this equation true? What number does C have to be for this to be true? 1. So that means my A is 1 and my C is 1. I go to my next equation, and I don't have a B and I don't have a D. So I got to go to the next side. There's no way to figure that one out. But the next one, I can see that 1B is equal to 3C, and we've discovered that C up above is 1. So 3 times 1 is 3. What does B have to be in order for this to work? B must be 3. Therefore, so far I have B is equal to 3. And then finally I can go to the second line. So this is a good example. I've discovered that B is 3. So 1 times B must be equal to 2 times D. Now this is a harder one to solve. So I have to divide both sides by 2 to solve. And this is just algebra. So I get that D is equal to 3 over 2. And here's a good example of what I was talking about. D is equal to 3 over 2. So that's my last one. D is equal to 3 over 2. And I've got to make a little bit room. There we go. Now I take my original formula and I put all of those things in front of them. Remember that A is in front of the first one, B is in front of the second one, etc., etc. And just do it like this. There we go. Which means that I have a 1 in front of my AL, or just AL. And then I have a 3 in front of my HCl. And then I have my right side of my equation. And my C goes in front of AlCl3, so it's just AlCl3. So I can just move this down. It's just a 1 in front of it, so there's no need to write 1. But in front of my H2O, I have this very odd 3 over 2. And I can't have it like that. So what's the only denominator I see? It's 2. So I'm going to multiply my right side by 2. So that means I have we'll have a 2 in front of my AL here. And I will have a 2 times 3, 6. So when I take that 2, right, the idea of algebra is you have to multiply what's in front of the AL, which is 1, what's in front of the HCl HCl, which is 3. I get 6. And then I have to multiply my right side by 2. So just so you know, when I multiply this fraction by 2, all that happens is you get rid of the 2. And when I multiply this one by 2, I get a 2, which means balanced out. This will have a 2 in front of it, and this will have a 3. And then you can just add up to make sure, once you're not too certain about how to make sure. If I add up the left side, I see I have 2 ALs. If I add up the right side, I have 2 ALs. If I add up the H's rather, I got 6 H's on the left side. And if I add up, I got 3 times 2 on the right side, which is 6 H's. And then finally, my chlorine, I've got 6 Cl's on the left side, and I've got 3 times 2 chlorines on the right side, which is 6 chlorines. And that all balances. And it's a wonderful system, and it's just great for people who are good at algebra and get frustrated by constantly doing the numbers back and forth. Okay, so we're going to go with this one now. This one's even more confusing, right? So we're going to just put an A, B, and C in front of each thing. A, D in front of that, and C in front of that. So it's going to be C over here, and a D. It's essentially a missing number in front of them, right? That's what algebra always is. And this one, we're going to do a C. Or sorry, a B, sorry. And on this side of the equation, I'm just going to do an A. I'll just move it over a little bit. Missing A. And then you start with each element. So on the left side, with sodium, the first one, I can see I have 3 in front of the A. And I have nothing else on the left side. And over on the right side, I only see it again, and I have 1 in front of the C. Then I look at my next element, it's potassium. And there's just one of them, so it's 1A. And there's no other potassium on the left side. And on the right side, I see potassium times 2. And it's with D. So it's got the bracket times 2. So there's 2 potassium, so 2D. If you don't know how to count up your elements, you'll have to need another video for that. And then on the left side, I can see I have oxygen, and I have 4 of them with the A, and I have no other on the left side. And on the right side, I can see I have O4, but it's in a bracket with 2, so I have 8 of them with the D, so it's 8D. And so that's that part. Now magnesium, I can see is with the B, and there's only 1 of them. And on the right side, I can see my magnesium has 3 of them with the D. And that's it. And then finally, chlorine. On the left side, I can see I have 2 chlorines with the B. And the right side, I have 1 chlorine with the C, and that's it. So I have 1 chlorine, and that's with the C. So I go back up top, and I make my A equal to 1. That's how you start it. That's just how you solve it. So if A is equal to 1, then 3 times A is 3 times 1 is equal to 1 times C. What does C must, 3 times 1 on the left is 3. What must C be for this to be true? C must be 3. Then I look at the next line, and I know that A is 1. A is 1. So A, 1 times 1 is 1. Must be equal to 2 times D. What must this be true? For this to be true, I have to divide both sides by 2. And I get D must be equal to a half, which means we'll solve it later. D must be equal to a half. You could solve it now, actually, by just multiplying all your fractions by whatever you, and we might try that actually and see if that works. And down here we know that 4A must be equal to 8D. We know that A is equal to 1 and that D is equal to a half. So it works out, right? Because 8 times a half is 4, so 4 is equal to 4. So we don't even have to solve that line. Down here we have 1B. We don't know what 1B is, but we do know what 3D is. D is a half. So 3 times a half is 3 over 2. Which means that B must be equal to 3 over 2. B is equal to 3 over 2. By the way, you can solve it all at this stage too. D is equal to a half. And finally, the last one down here, 2B, which we know is 3 halves, is equal to 1C. So if I multiply this through, 2 times 3 1/2 is equal to 3. We get C is equal to 3. We already knew 3. We already knew D. So we have all our solutions already. So I kind of did that erroneously, but it's a good way to prove it. Now, if you don't want to go and multiply up top, you can just multiply these because C and D are on the left, right? And A and B are on the right. And we can see the common denominator is 2. If we multiply each thing by 2, we get this. There, problem solved. Which means I can replace my A with 2. Get rid of that comma. Don't need it. My B with 3. My C with 6. And my D is just 1. Now, if you really want to count them all up, you can. How many sodiums do I have on the left? 2 times 3. I have 6 sodiums. How many sodiums do I have on the right? 6 in front of the first compound. How many potassiums do I have on the left? 2 times potassium, so I have 2 potassiums. How many do I have on the left? I have 2 in the bracket, and there's bracket as a 2 subset, so 2B. Then looking at my oxygen on the right, I have 4 times 2, so I have 8 oxygens. And on the right side, I can see that I have O4 times 2, and there's nothing in front of it, so there's 8 oxygens on the right. And magnesiums, I can see that I have 3 of them there, so there's 3 magnesiums on the left side. And on the right side, I can see it's Mg3, and there's no D is 1, so there's 3 Mgs over there. And finally, my chlorines, I have 2 on the left side times a 3 multiplier, so I have 6 chlorines. And on the right side, I see the 6 in front of the NaCl, so I have 6 chlorines, which means I have a beautifully balanced equation. Algebra, in my opinion, makes this much easier. And finally, the last one. If this is A, and this is B, and this is C, and this is D, clearly starting with nitrogen, there is 1A on the left side, and on the right side, there's 1D. Going to the hydrogen, there's 3A, and on the right side, there is 2C. Okay. Going on to the oxygen, there's 2B, and on the right side, there is oxygen, there is 1C plus 1D. There's my mistake right there. You're going to let A equal to 1, therefore D must be equal to 1. Down here, if A is equal to 1, 3 must be, this must be the equation. So C is equal to 3 over 2. So that was right. Down here, I don't know B, but 2B, if 1C, there's the mistake, is 3 over 2, and 1D, and D is 1, I get 3 over 2 plus 1. If we put them as fractions, 3 over 2 plus 1 is the same as 3 over 2 plus 2 over 2, which is 5 over 2. Whenever you divide, or if you multiply this by a half, and multiply this by a half, there's my mistake. B is equal to 5 over 4. So now if I rewrite them, A is equal to 1, B is equal to 5 over 4, C is equal to 3 over 2, and D is equal to 1. The lowest common denominator is 4, so if I multiply everything by 4, I get this. This becomes a 2 up top times 3 is 6, and this becomes this. Now let's try it. Very stupid and easy mistake to do. If you don't know how to divide a fraction, by the way, it's always double the denominator. Now let's try it. You guys probably caught it on the video while I was doing it. It's good to make mistakes, though. You learn more from mistakes than you do from anything else. It's what people don't realize. People hate mistakes, but you will learn more from mistakes than anything else. Now counting up on the left, I have 4 nitrogens, and on the right, I have 4 nitrogens. On the left, I have 12 hydrogens, and on the right, I have 12 hydrogens. On the left, I have 10 oxygens, and I have to add up two separate things. I got 6 oxygens plus 4 oxygens, 10 oxygens. Woo! Mistakes are good. They're embarrassing, but they make you learn.